What's up guys, it's Mr. Hansen, and today I'm here with a video for simplifying expressions. We're starting expressions in algebra. So a lot of the stuff is about, what makes up a number sentence and variables and operations and coefficients and all that good stuff. So if that's what you want to learn about today, you're in the right spot. So let's go. So I'm going to record. I'm using Kami. I don't love it. I only got a free trial of 50 days though, so we're going to make the best of this while I got it. So I'm going to switch to my display real quick. There we go. I want to hang out over here today. So here we go, guys. Variable expressions. I'm going to be bouncing back and forth. I got my double monitor set up, so if I'm looking, don't trip. I don't have a tripod for this webcam yet, so I'm going to have to get that. So here's some vocab. Write it down, learn it. Vocab's kind of just like something you got to know. You got to be able to speak the language, right? If you don't know what something means, you could probably figure it out, but it's good to know. So a term is just a part of the expression. So all those things at the bottom are terms. Coefficients, it's a number in front of a variable, so it's a value that you're multiplying. So you have 5x, that means 5 times x. There's 5 of them. Constant term is just a number, so a constant term doesn't change. Any regular number is a constant. Make sure you know that. And like terms can be added together. So numbers can be added together. Variables with the same letter can be added together. Think about like apples and apples, oranges and oranges. Things that go together go together. All right, so on this part, guys, pause the video right now. Pause. Hit pause. Well, in a second, right? Try it. So you see that it tells you right here to label your terms, your coefficients, your constant terms, your like terms. Do it. Do it right now. Pause. You paused yet? All right, you better be, because I am going to now go through this. So the terms are just everything. So this is a term. This is a term. This is a term. This is a term. Those are all your terms. So you'd write those here. Your coefficients, those are the numbers in front of the variable. So we have two variables, right? Two p's, 6p and 23p. So your coefficients is the 6 and your coefficient is the 23. The constants don't change. So numbers, plain numbers don't change. They're just going to be numbers. They're going to be the same number that they were unless something happens. And this is a constant and that's a constant. And then like terms. Well, take a look. You have 6p and you have 23p. You can add those together because they're the same thing. They have the same variable term. And then you have -7 and +2. You can add those together because those are like terms. Now, notice how I underline the variable terms once and I underline the constant second. That's a way that I keep track, because sometimes you don't have these fancy pen colors that I have right now. So pause it again, do number 2. All right. So right away, like term. I got my coefficients, the numbers attached to the variables. All right, 13, -5. Got my constants. Constants are just my numbers. So -4. Oh, that should have been green. Sometimes it doesn't pick up right away. -4, -6. This is my Star XP pen tablet I got on Amazon. It's straight. It's not perfect, but it does the job. So if you need something, let me know. Oh, that should be there. And then like terms, you add those numbers together. That's why I'm color coding. My lime greens go together. Chirping. Target's trying to get me to go shopping. And then you got your coefficient terms, your variable terms, 13c, -5c. Boom. So hopefully you got the same answers as me. If not, you might want to pause right now, write down some questions, hit me up in a second. Well, here's some more practice. You can see right away very clearly, those are my variable terms. There's my constant terms. Hopefully you know what the coefficients are by now, 2 and 6. All of those are terms, so that's 4 terms. Here, same deal, just because it looks a little different. These are your variable terms, constant terms. I know I'm going a little quick, but hopefully everything's making sense. So here we keep moving on. More practice. This is how much I care about you guys. I'm giving you free practice. That's like go and do see a coach and they give you free drills. That don't happen. So you can pause this. You can try these out. Any ones that you don't understand, hit me up. You know how to get a hold of me. Combining like terms. Now this is a big deal because you got to be able to put things that go together. I kind of think about it like putting away the laundry. I want to fold clothes for you. I want to make you feel good. You know, you bring the laundry up, you fold everything. But then how do you know what goes where? Well, hopefully you have a system and like all your jeans go together. All your socks go together. All your t-shirts go together. All your jackets go together. And you put them somewhere. You're probably not putting your jackets and your socks in the same place. And if you are, your room's probably kind of messy, which mine kind of is right now. But hey, we ain't going to talk about that. So combining like terms, if they have the same variable, you can put them together. So for example, and it's literally is what it sounds like. If you have a 2x plus a 3x, because they're both x's, you can put them together. 5x. Some of you probably have more than that already. Distributive property. That's just multiplication for more than one thing. Think about like the mailman. You got to be out here distributing your mail. Hopefully the mail's still coming by you. Got to make sure we protect that post office. What you cannot do, so this is bad. Don't do this. You can't go 5x plus 2 and equals 7x. Nope. Or equals 7. Nope. You can't mix them together. That's like oil and water. It don't work. It's like ketchup on tamales. I know somebody does that. It's disgusting. All right. So here we go. Let me tell you how to do this. So we have an expression, 12k minus 9 minus 7k plus 20. So the first thing I want to do is make sure that I identify my variable terms. So variable term, constant term. Now it says use the commutative property to move all the terms together. So basically you can rewrite this, and I'll do it once. I can tell you I really don't do this. I don't see the need most of the time, but I'll do it. So I'll put my variable terms together. So I got 12k minus 7k. That property allows me to do that. Math magic. Okay. Gives you powers. Then negative 9 plus 20. All this does is helps you sort your laundry. That's all you're doing. You're just moving things around. You didn't do no math yet. You're just moving things around. And then it says for step 2, so we're done with 1. Step 2, combine the like terms by adding or subtracting the coefficients. So in this case, 12k minus 7k. If you have 12 koalas and you release 7 into the wild, how many koalas do you have left? Well, you have 5 of them. You just subtract 5 minus 7. And then for the constants, oh, that should be purple. Now let's switch it up. Let's use teal. You got negative 9 and positive 20. Now knowing that 20 has the greater absolute value, and if I start 9 feet underwater and I go 20 feet above, like I'm a orca or a shark or a whale or something that can jump, I'm going to end up 11 feet above sea level. I'm going to get plus 11. Now some of you might keep going and be like, oh, I got 16k. No, you don't. That don't work like that. This is what you got. You have simplified fully 5k plus 11 because your variable terms are all combined. Your numbers are all combined. That's like, hey, I got my socks and I got my t-shirts. Don't put them together. Leave them apart. Make sure there are no more like terms. That just means like if you had like a plus 2 at the end, throw it together. Whatever you can combine, combine. So if you want to pause the video, rewind a little bit, go back and get this, I suggest you do that. Put it in your notebook. Oh, yeah, trying to pause. All right. Practice time. So here's 4. Pause the video. Do it nice. Show your work. Because if you make a mistake, you want to be able to check. So I'm going to write some of the answers here. I'm not going to do all the work because I don't got time for that. What I will do is I'll underline my variable terms and I'll underline my constant terms. Now, you don't have to do it my way. If you did it another way, as long as it makes sense and you can explain it, I'm cool. Now, if I have negative 7b's and like if I owe somebody 7 boats and I get 1 boat, well, now I still owe people 6 boats. So that's a negative 6b. And then a 3, a positive 3, and a negative 10. If I have $3 and I use my debit card for something for $10, I'm going to be owing some with overdraft fees because I'm going to be negative 7. Can I simplify that anymore? Not at all. We're done. Don't turn that into like a negative 13b or a negative 1b. Don't do any of that weird stuff. This is done. These are your socks. These are your t-shirts. These are your apples. These are your oranges. We're done. Let's see. I got my negative 8x and a negative 3x. So I know that's going to be a negative number because they're both negative. Getting more negative. That's a negative 11x. Positive 16, positive 9 makes a 25. It's a good number. I like that number. We got our constant terms. I generally will, I didn't do it. I was going to say I was going to do. I generally try to underline my variable terms first, and then go farther down, especially like when you guys get into like higher exponent stuff with quadratics, but it is what it is. So I'm going to go back and I'm going to do these first though. So 8w and negative w. If I take a w away, I got 7. And a 5 and a negative 6. It's what negative has the bigger absolute value, so it'll be negative 1. Last one, a little spicy. A little pepper on it. Nothing crazy, though. It's got 3 x terms. Just add them all together. So what's negative 3 plus 5? Well, that's positive 2. Positive 2 plus 9 is 11. So 11x. And then a 4 minus 12, that's negative 8. Whoa. That looks like that alien. That's super ugly, though. That's a negative 8. So you should be good, hopefully. If not, maybe go back and check your work, but you should have my answers. And if I did something wrong, let me know in the comments, please. Distributive property. Now, distributive property, all you got to do is think about multiplication. You're just going to multiply more than once. So there's more than one way to write things, and that's where this whole equivalent variable expression comes from. Things that are equivalent are the same value. Like I can give you 4 quarters, or I can give you $1. So what was going on here is we're saying that this 9, when it's outside of the parentheses, it's 9 times the 3 and 9 times the positive x. You're multiplying both, and I draw those little rainbows. And you can rewrite it. You can write it as 9 times 3 and 9 times x, which really is just 27 plus 9x. So distributive property is super powerful. It's just an easy way to do more than one-step multiplication. If you have questions about this idea, let me know. I can make a more detailed video if I had to. So you can still simplify expressions with parentheses, but if you have parentheses, the goal is to get rid of them. So it says for step 1, distribute. So basically this is adding one step before what we just did. So instead of just jumping to adding and subtracting, like if you try adding this b to the 4b, you can't. It's in the parentheses. It's trapped. You have to release it. Let it out of the parentheses first. So we're going to take this 5. You're going to times it by 6. And I draw my little rainbows. I highly recommend it. And then I'm going to take this 5 and I'm going to multiply it by the b. So 5 times 6 is 30. You got to know your multiplication, guys. 5 times b, that's really 1b. That's a 1 dotted in dots. You do 5 times 1. You multiply the coefficient. So it's 5b. So plus 5b. Bring down everything else. We didn't touch it. We didn't multiply. We didn't do anything. So plus 4b minus 9. That should look familiar, right? Like you've seen this. So you underline your variable terms. 1, 2. You underline your constant terms. 1, 2. Group them. So simplify. Combine like terms. You got your 9b and you got positive 21. Now this is a bonus, super bonus just for being here. You can factor out and undistribute. So if you look at the 9 and the 21, what do they have in common? They both have a 3. That's their common factor, their GCF. So you can pull that 3 out and then rewrite this as 3b plus 7 if you want to get extra spicy. We're not doing that right now, but just for being here, you got to learn something extra. So here's some practice. That looks like a 2. It got cut off kind of weird, but it is what it is. So I would pause this and go ahead and get some practice in. I'm gonna do just one of these, and I'll do number 2. Number 3 looks hard. But see how it's just a negative sign? Here's the trick. When you just see a sign, it's a 1. There's a 1 there. There's always a 1 there. If there's something there and you don't know how many, and it's just a letter, it's a 1. That's a 1. I'm gonna do number 2 though. So first, before I can add anything and simplify, I need to multiply using the distributive property. That's a negative 3. Don't forget that negative's there. So it's going to be negative 3 times 6 and negative 3 times negative y. So I'm not touching 10y. I'm just going to drop it down. Negative 3 times a positive 6. A negative times a positive is, yeah, it's a negative. When the signs are different, it's a negative. Negative 18. That's only for multiplication and division, though. Don't get it twisted with addition and subtraction. Negative 3 times negative y, negative times a negative, positive 3y. Can I combine anything? Do I have any like terms? I don't have any common constants, but I do have common variables. So I'm going to get 7y minus 18. So I'm not going to write the answer to the other ones. If you aren't sure, let me know. I can help you out. We're getting to 15 minutes. I wanted this to be about 15 minutes, but we're going to keep going. I got nowhere else to be yet. So let's scroll down. So this is just a little bit of application. I know some of us learn better by thinking about things that you can use this for, and this is useful. Now, I'm not saying that you're going to go out in the wild and like make a fence doing this, but it can help you understand things. So we know perimeter is the distance around. Establish a perimeter, set a perimeter, keeps the outside. You make out a wall. There's the formula. P, perimeter, is equivalent. So that equals that to 2 times length. So the coefficient's 2 and 2 times W. Now, can you add 2L and 2W and get something? No, because they're not like terms. Make sure you don't switch that up. All right, so we have the problem. A rectangular frame, 5 inches longer than it is wide. Okay, so think about what that would look like. Write and simplify an expression for the frame. So, well, I might draw a picture first. So if it's 5 inches longer than it is wide, well, if my length is 5 of them and the width is only 1 of them, it's probably going to look something like this, right? Well, let's write it out. So if we know the perimeter, right, it's going to equal some combination of length and width. All rectangles have a length and have a width. If the length is 5 inches longer than it is wide. Oh, I said that wrong this whole time, by the way. It's not multiplied. 5 inches longer. So 5 inches longer. How would you write that? Well, it's going to be W, right? There's the width. How long is the length? We don't know, but we do know it's 5 inches longer than the width. So we can say that the L is equal to W plus 5. So let me just clarify what I did here. I don't know length in terms of L. They didn't say length is this. What they said is length is 5 inches longer than it is wide. So what I'm going to do then is write my formula, my perimeter formula as 2W. I'm putting W first because I can. Plus, now instead of writing 2L, what is L? It's 2, but 2 what? 2 of these. 2 of these W plus 5s. So W plus 5, width plus 5. Now, if you want to go ahead and figure this out, what you got to do is distribute first. And this is not my best work. I'm going to be honest, but it is what it is. So P equals 2W plus 2W plus 10. Add that together. You're going to get 4W plus 10 as the perimeter of this rectangle. Looks like we got some practice for you guys. Just find the perimeters. Add them up. Pause real quick. I will write the answer to like one of these real quick. I got time for that. So for this one, what I would do is first I'd probably just copy, you know that it's the same. That's the same. But then remember your formula. It's P equals 2L. So L is 2x plus 5. Now you're going to get the same thing if you just add it, but this is good practice with multiplying. And 7 times 2. Being a little messy here. End of the long day, guys. Remote teaching is hard work. Triangles, you can just add them up, add them up, add them up. So we'll add up these guys, 20x. Add up these guys, 18 plus 14 is 32. That's the perimeter. Now perimeters require units. These don't have units. These are pretty generic. So that's perimeter of these shapes. So here's the challenge before you get out of here. An exercise mat's twice as long as it is wide. Just write the expression. Make that happen. So what we learned today, let's recap real quick. So there's me. Expressions, simplifying them with variables in them. There's terms, coefficients, constants, like terms. Make sure you know them. Make sure you know how to find them. Make sure you know how to identify them. Once you know what they are, you can pick them out like we did there. And then you can start simplifying by combining like terms. So you can put your x's together, your y's together, your numbers together, put your x's together, run them over with a truck, do what you got to do. And then distributive property is just a way to remove parentheses. It's a way of multiplying a number on the outside by everything on the inside. So every letter, every variable, every number. Make sure you multiply by everything. We showed how that looks, and then you can regroup at the end. You can combine like terms. Again, I also doing that little bonus factoring. And then we talked about perimeter and perimeter's application of this. So that's what I got. Stay with me for 20 minutes. Props to you. Again, go back and rewatch this. Rewatch the parts you need. You're jotting notes down. I'm going to throw up some more work in the future. Hit that subscribe button. Thanks you guys for tuning in at Mr. Hanson 414. I'll see you guys later.